Today's lesson is solving linear equations. Basically, the key concept is to find an exact value for a variable that matches an equation, that makes an equation, i.e. the left and the right, be equal. So we'll do that by using some of the tricks we learned from past years. Now, for the first problem, we have 17 plus x equals minus 3. So some of you learned that if I wanted to remove something from the left side, what we did was we would, if it was positive, we subtracted it. i.e. if we changed the side, we changed the signs. So, for example, I know that 17 is here and I want x by itself. So what I'm going to do is I'm going to draw an arrow to where I would like it to be in my next line. And then I would rewrite my equation with x by itself equals negative 3. And then instead of plus 17, it has to be minus 17. And then we simplify to get x is equal to minus 20. Try the next problem and I'll show you a similar solution. For the next problem, the key idea is to isolate. The word is isolate. Single out 4p. Now, since we want 4p by itself, what we're going to do is we're going to take the 12 that's on the left side of this equation and draw an arrow to the other side. Now, just like we said, anytime we change the side, we change the sign. So we have the following equation for the next line. 4p is now by itself equals 15. And then instead of being plus 12, moving to the other side, it becomes negative 12. Now, we now must collect like terms on the right side of the equation to get 4p equals 3. To get 3 by itself, to get p by itself, we must divide both sides by 4. So in the end, we have p is equal to 3 over 4, or if you changed it into a decimal, 0.75. Moving on to the next set of problems, we'll use the same concept as before. We isolate the variable that we want. In this case, we're looking to isolate negative 5n. And we're going to move 17 to the other side of the equation, and we get the following. With negative 5n isolated by itself, we get negative 2 plus 17, which is equal to negative 5n is equal to 15. Now, since we have a negative 5 sitting in front of the n, we're going to divide both sides by negative 5. And we end up with n is equal to negative 3 as our final answer. For question number 4, anytime you see a fraction sitting on any problem, what I'd like you to do is look at the lower part of the fraction we call the denominator. And what I want you to do for that is to use the denominator and multiply it against every number in the equation to start. And then your problem will go from something that looks like this to something that looks like this. In mathematics, we always take something that is more complex and put it down into something that is more manageable. And I know you guys hate fractions, so let's get rid of the fractions here. So if I multiply this by 3, and then this by 3, and then this by 3, you'll find the following. The 3 and the 3, when multiplying 2 over 3 times 3, the denominator disappears, and we're left with 2x minus negative 1 times 3, we're using our waterfall method again, is going to be minus 3. And then 5 times 3 gives us 15. Now that looks pretty simple. We want to isolate 2x, so now we're going to move the minus 3 to the other side, and in doing so, we end up with the next line. 2x equals 15 plus 3, which is 18, and so 2x is 18, and then we divide both sides by 2, and we end up with x is equal to 9 as our final answer. And now for our final problem. Basically what we have to do is we have to think about how we're going to isolate for hem. In this case, for this problem, you notice we have an m here and an m here. Key idea is to basically move all the m's to one side. In this case, I'm going to choose to move all my m's always to the left. So in this case, I have my m, my 7m that's on the right side, and I don't want it there, so I'm going to move it to the front of this equation. Alright? And now, in doing so, we now have, instead of 7m, we have minus 7m minus 2m plus 14 equals, well, 7m is gone, plus 23 is just 23. Now for our next line here, I'm actually going to isolate. I don't want any numbers, any single constants by themselves here. I'm going to move this 14 to the other side behind the 23. In doing so, we get 23 minus 14 on the right side, and on the left side we have negative 7m minus 2m. Now let's simplify and collect like terms for both sides. So we get minus 9m for the right side equals 23 minus 14, which is 9. Now we'll divide. Now in order to get rid of the negative 9, we divide both sides by negative 9. And we get negative 1 for our right, and m is equal to negative 9. The next problem involves us first expanding or distributing the 3 into our bracket just like before. And we'll do that right now. And what we should get on the left side is now 3x plus 12 is equal to negative 15. Now we're going to make sure our 12 is not on the right side because we're trying to isolate, i.e. get x by itself. And we're going to take 12 and move it to the other side of the equation behind the 15. So now we have negative 15 instead of plus 12 minus 12, and 3x by itself. Simplifying, we get 3x is equal to negative 15 minus 12 is minus 27. And for our final step, we're going to get x by itself by dividing both sides by 3. And we get x is equal to negative 9. Our next problem is an ugly problem, and this is probably the most difficult type of problem you'll see on your homework for this day. You'll notice that each of these have their own denominator. The lowest common denominator that all these numbers, the 5, the 2, and the 4, can be divided by is 20. We call that the lowest common multiple, which is going to be 20. In this case, we're going to take 20 and we're going to multiply each of these numbers sitting in front of the brackets and fractions by 20. So now, 2 over 5 times 20. So that when you multiply that out, you're going to get the following. 8. And then you're left with x plus 3. Equals, well, 20 divided by 2 is 10x minus 15. So now we're back to distributing 8 into our x and plus 3. And we're left with 8x plus 24 is equal to 10x minus 15. What I want now is all my stuff, all my x's to the right, to the left side, and all my numbers to the right side. And so here's what we're going to do. I'm going to actually just sort of draw it for now, and then later on when you get better at this, you can do that by yourself. Notice how I'm always drawing to either to the end of the list or to the back or to the front of the list. I'm going to move all my numbers to the right side. So now I'm going to get 8x by itself equals 10x minus 15 minus 24. I want to get rid of 10x, so what I'm going to do is I'm going to move it to the front of the 8. So now that ends up being 10x, instead of 10x is going to be negative 10x plus 8x is equal to minus 15 minus 24. Simplifying both sides, we get minus 39 for the right side and minus 2x. To get x by itself, divide both sides by negative 2. And we get x is equal to 19.5. Now, for the last problem in this whole solution set, the key is the following. When you do the problems and you see waterfall type problems, i.e. distributive problems, you need to do those first, always. In doing so, you're going to get the following line. And we get this line. You'll notice that when we took minus 6 and multiplied into this bracket, we got minus 18t minus 48, and 3 times this bracket gave us 3t minus 15. Now what we'll do is we'll collect like terms for both sides and then start moving things across. The like terms on the left side are the constants, which are here and here. So 3t is left by itself, and we now have minus 15 and plus 12, which gives us minus 3. Now I'm going to rearrange all the numbers on the left side of the equation so that things that are similar are together. So I get 2t minus 18t minus 9 minus 48. Collecting like terms right away, we end up with, on our right side, 2t minus 18, which is going to be minus 16t. Minus 9 minus 48 is minus 47. And we still have 3t minus 3 on the right side, left side. Now we're going to isolate for t on the right side, on the left side of the equation. So you'll notice I have a 3 on this side. For now, I'm going to circle it. Eventually, you're going to get better at this. We're going to move 3 to the end of the line on the other side, and we get negative 16t minus 47 plus 3. And we have 3t left on the other side. And now, I'm not going to simplify. What I'm going to do right away is I'm going to move my negative 16t over to the front of this 13. So now, 3t. So now we have the following. 16t. Now, because there's no sign in front of 3t, we're going to say it's plus 3t. And we have minus 47 plus 3. So minus 47 plus 3 is minus 44. 16 plus 3t is 19t. And now, in order to get our information isolated, our t's isolated, we divide both sides by t, by 19. And so we get t is equal to negative 44 over 19, or some ugly looking decimal. So your homework is the following questions. Page 4 and 5, 1 to 3 ACE, 6 ACE, and G, I, and K. Good luck, guys. The notes are online. You can try some of these over the weekend, and we'll finish up on Monday.